All right, I was on a little kind of short road trip, so I haven't made a video in a while. We kind of messed with kernel stuff. I think it was the kernel the last video. Maybe there was one after it. Um, and we've got a lot of stuff to do still. Um, I think around video, this should be 19. I think in around video 20 or 25, I'll do like a recap of like what the plan is and everything. But for now, we're just going to kind of keep chugging along and get some more basics in place. Um, I am going to try to do a line drawing algorithm. We have horizontal and vertical line drawing already, but they're very simple since um, they just iterate, left to right, top to bottom. But for arbitrary lines, we need something more to rasterize a line, something a bit more robust, like the Bresenham. I might be mispronouncing it, but the Bresenham line algorithm. I have implemented it probably 5 times, and I never truly understand it. I've done it from like Pikuma's 3D course, and then had variations of it ever since that I just have copied and pasted to different projects for all my software rasterizers. So I was going to do like a bunch of research before we started so I could really understand it, but I think I'm going to show it as a little bit more of a realistic way to do it. I don't think you're supposed to have stuff like this completely memorized or anything, but you're supposed to implement it once where you understand it, right? And then you can always check your comments or review later. But with all the stuff we've done, I feel like I should get feedback. I think I should definitely understand a simple line drawing algorithm. Um, it'll kind of be cool. I think after that we can start implementing. We can have more types like vector types, and we can get into triangles, and then filled triangles, even textured triangles, um, and maybe have an app just draw some 3D cubes because I kind of want to get in our AK library all our standard or kind of primitive types. I guess they're not fully primitive, but we're going to use Vec 2, 3, and 4, and Mat 4x4 like a matrix throughout our a lot of our projects. So I'm going to make those top level things like we did with strings and string view and our memory allocators and put them in our AK library. And then when we need more advanced, not more advanced, but more complex types like vertices or vertex type, I'm pretty sure those are going to be per application because they're so application specific. Sometimes you want a color, sometimes you want UV coordinates, etc. I'm sorry if I'm getting feedback. I don't know if it's too loud or I'm still trying to figure out this microphone. Um, I guess I can minimize that. So yeah, we'll do that. But this is more in the next couple videos. If we have, I was trying to figure out how we could do a really generic-ish rendering pipeline, and I actually never knew how to do it in C. But in most of my projects, I always had a single vertex type, with the stuff that I wanted: texture coordinates, color, um, the 3D coordinates. But every project's a little bit different. But I saw a way. I actually on my road trip, I was literally talking to ChatGPT about ways to do it so we can have a unified rendering pipeline for 3D little apps and stuff. And it suggested doing function pointers to extract the data. So you would pass in your vertex as a void pointer. Like a function would be set up where you pass in a vertex and it returns, like a vec3 or a vec4. So when you do the rendering pipeline, you pass it a void pointer to your vertex data, but you also pass in a function pointer. It's essentially a getter. But so when you call it, you can pass in your data and the pointer to extract that data. And I thought that was pretty sweet. I don't know if that's really the super common way, but it's kind of how, or it's not kind of, it's how the sort algorithms work in C. So I feel like it's probably pretty idiomatic. I've just never done it. And it seemed really simple and interesting. So it won't come to fruition until we have a couple apps with different vertex types, but it's pretty cool. So let's not get too far ahead of ourselves, though. We're going to just draw a line today. I might even ask Google AI thing to describe it without giving us code, so we have a guideline, because I really don't have it memorized. I don't even 100% know how it functions, but I glanced back at one of my other implementations, and there's still parts I don't understand. So I think we're just going to dive in and see if we can't figure it out. We might get a little help, but I don't want to ask for the code to do it. I just want to ask more for the kind of the shape of the algorithm. So let's see where we are. Do we have everything, the newest stuff? Do we have our branch? Oh, yeah, so we have our kernel branch. We haven't merged that in. I threw a lot of that code in there. Man, I'm still getting that crazy feedback. I'm sorry if that's kind of blasting. Input, output. Man, I almost want to turn the volume down a little bit. I hope that's not too low, but I'm getting popping. Yeah, so I haven't merged the kernel stuff yet. I might not, because I haven't 100% decided. I think that lemony or lamine or whatever it is probably the way to go, but I copied in a big make file and did stuff. It was kind of the antithesis of what we're trying to do. Like, I want to know what those flags are, why we're doing them. I've not committed to merging that in yet. We might do a little bit, now we know what's going on, we might do a little bit cleaner implementation first. So let's see where we're at. And just to make clean. I still like all this. Oh yeah, that's what we did last time. We need to add scroll bars, but we do have scrolling. That's pretty sweet. We'll quickly get some UI elements, like a scrolling text widget, scroll bar, buttons, and we'll start building out like our UI language so we can have nodes and vertical splits, horizontal splits. I've never done any of that stuff, but I've been doing a little bit of research on it, on how we want to do it, and I think it'll be really cool. I kind of got a vision where it's going to go, but I haven't like materialized it before, so. All right. One thing that I've seen 50 times that's been bugging me is these includes aren't necessary. Another thing, it's not a derail, but I think I'm going to pull stood it because of the kernel stuff. I'm trying to reduce what I'm importing, and this one's actually fine to import because you still get it with the compiler, I think. But some of the other ones, I'm trying to minimize it so it's easier to port to our kernel. So we could change these to, probably not that, but we can do this for each one, then unsigned short, unsigned int, unsigned long, and so on, then signed versions. But let's not worry about it for now. All right. So we want to draw a line. Where's our drawing stuff? Yeah, so we have these horizontal and vertical. They're very simple. So let's just steal one. We're just going to call it line because it could be arbitrary. And now instead of x, y, and a length, we want to like x and y starting point, and then x1 and y1. We could pass in 2 vex in the future. And this is kind of a bummer because I was going to do, I don't know, like something. A V would be cool for a vector, like have a pattern where you can do raw, but you can also pass in P0 and P1 and their vec2s, but let's not get ahead of ourselves. Did I do what I think I did? Yeah, okay. So we can draw a line. Let's go into our draw implementation. So how are we going to do this? Let's do what we said. Can we just... Is it Bresenham or Bresenheim? Yeah. And what's the way to be terse? Terse? Don't be verbose. So you're basically, you set up the points. I know that first, where you're ensuring you're going from left to right. So you swap points around. You can swap X and Y, and then you can swap X, O, and X1. Because you want to go left to right, but you also handle if it's steep. Like the Y is longer than the X, then you swap as well. And then you iterate left to right, and there's this error accumulator, and I kind of get it, where you have a perfect line in mind, and you accumulate this error to see if the Y changes as opposed to the X. And if it does, then you increment Y, reset the error, and keep going. And I think the error always confused me, because it's not really an error, but I think it's more of a mathematical term, like error in the sense of mathematics. And it's a common word. I never liked it because I think it threw me off, but it's so common, and it's pretty much the industry standard for it. I think you will still use error as the variable name, like the error accumulator, because if anybody else sees this and they're familiar with this algorithm, they'll be expecting that. So I don't want to deviate. All right. I don't know about that. Yeah, like this. This is what I was saying. Swap the roles of X and Y. That should be step one. Why are you telling us? I feel like this is the first thing you do. Instead of adding 1 or y, subtract 1 based on the sign of dx and dy. This I do know too, that you do like a ternary operator on if. See, based on the sign, like you do subtraction, and then you check which one's larger, and then you can make the step -1 or +1. Let's just do it based on this and see where we can get. So I think this is important first. Swap the roles of X and Y. This is good. Let's see if it'll give us a little bit better. Oh, well, don't give us the code. God dang it. It's still not. All right. Well, let's cheat a little bit. I know I have an old one. I don't know, how old is this? 3 years. I probably did some. Oh, I just upgraded it, so it's years and years old. But this was a pretty decent software renderer. I don't really know. I'm not a great C++ developer either, so there's probably plenty of stuff. So these are all my draw things, but this is for like 3D rendering, not really 2D rasterizing. But to do 3D, you have to do 2D rasterizing. I don't know. We can kind of use this, but I want to understand it as we do it. But I do know this. We're testing if it's steep. If it is, we swap, just like we said. And if x is greater than x1, so if the starting point is to the right of the ending point, then you swap that, right? That makes sense. So let's just do that first. We're going to have to create some functions. We are steep. Sorry, I've got a new laptop for work, so I'm setting it up in the background. Sorry. All right, so this is the length of y, and this is the length of x. So if it's taller than it is wide, then it's considered steep, and then we do things based on it. So we need to do this, but we don't have absolutes. We don't want to use theirs. We want to do our own. So we're going to be working with I32s right now. So let's just do more of the same here. We need absolute value. So I32 absolute. What if value is less than 0, then we return the negative value. Otherwise, we just return the value, right? That makes sense. Right? So is steep equals, what did we say? Y1 minus Y0. If that is greater than X1 minus X0, then we're steep. And if we are steep, we want to swap X and Y. So if is steep, we need to have an I32 swap of what? X0 and Y0, and X1 and Y1. That makes sense, but these are probably going to have to be pointers. And again, we're not you can obviously use macros for this to make it work for I32, F32, etc. But this is our own project, so we're just doing type safe stuff everywhere. Just why not? If we don't like it in the future and it becomes cumbersome, then cool, we'll swap. This is actually going to have to be, we're not going to have room. So let's make it A, then make A equals B and B equals 10. Right? Wait, we're not returning, it's void. I don't think our editor is going to let us put it on a single line. Kind of a bummer. And let's do something. We need real tests, but we just want to, let's make a function that we can just call. that will just exercise this real quick for us. So we're going to assert that negative 42 is the same as, no, let's make it 42 and then negative 42. We want to make sure the absolute value. And then A equals 5, B equals 10. And let's throw one off. I want it to fail. That's why we're. It's complaining because this function's not ready. We should get some asserts. Yeah. So that's right. That should be 42. The other one, A equals 9. A should equal 10. This is super temporary. This is just some sanity check on our functions before we like depend on them. We don't want to depend on them if they're fundamentally broken. All right. We also have this, yeah, let's not care about that. So if we're steep, we swap those, that makes sense. And if we're drawing from right to left, we want to swap it so we can have like a uniform iteration from left to right on X and Y. So that makes sense. So if XO is greater than X1, then we want to swap them too. Although we don't want to swap that. We want to swap X1. I think that makes sense because we're swapping. Yeah, you're swapping the points. That's all you're doing. The X and Y of this and the X and Y of this, you're swapping them. So it's left to right. All right, this is where we don't know. So, oops, sorry. I'm not used to the microphone. So let's just see if it makes sense and then instead of just copy and paste it. So these are the two lengths of them, and they called that. They didn't. I used to think delta, but it's not delta. It's no, it's not that one. Did he say it again somewhere else? Yeah, they're the length, not like it doesn't stand for delta. Do they? What do they call them? Those aren't dy. It's not a decision variable. Yeah, just the differences. I guess I don't know what the term is. So that makes sense. We need the absolute of y because here we swapped them. So we're ensuring that x is greater. So we don't need absolute. That's fair. I mean, you could do it just for consistency, but I want the absolute of y1 minus y0. This, I keep seeing this division by 2, and I've seen it say like it's half pixel, but it's not. You're getting half of the distance. Why would it be half? That I don't understand. Yeah, let's just do that, and then we can test it out when we're building it. This would make sense. What's the step? Because we're the y as the error accumulates, then we're going to step y down. You know, if we're kind of incrementally drawing down, but if y is if y, yeah, we're starting from top to bottom. So if y is less than y1, we're drawing down, and the increment will be positive. But if we're drawing up, then it'll be negative. So that is perfect sense. Y step equals otherwise it's -1. What's this for? Do we increment that? Yeah, so you're starting y0 is the beginning. We're just going to set it as y. And then when we accumulate the error enough, then we're going to step the y by plus or minus. So then, okay, yeah. Because you're not going to change y0, but y will grow. So the reason we swapped x and y is so you can have this consistent x plus plus. So x equals x0, x is less than the end. Oh, and then if it's steep, it's a lot of branching. If it's steep, then you draw. What was the point of swapping these if you're having to do it again here? Like, this kind of would make sense to me if you said is it steep, but you didn't swap it. It seems like you normalized it right here. Why do you still have to account for it? Let's do it without, let's just do it normal and see what happens. All right, so for, are we just, yeah, x0, x is less than or equal to, should that be less than or equal to? Yeah, because x1 is, yeah, no, that, yeah, because you could draw on the, like it might need to be just less than, draw pixel, surface, what color do we want to draw? Let's just do red. We don't want to do that per pixel. That's stupid. This is the U30T, U32. Instead of like the struct. So we're just going to pack it once so we don't have to do that function call for every pixel. All right, so we're drawing the pixel. I'm going to leave out this bit for now just so we can see. So the error accumulates, the negative. So we have the distance x to y. Error subtracts dy. What does the error start at? Half of x? The error is half of x. Sorry, at half of dx. Error minus equals dy. So we're drawing 10 pixels, say it's 5. Hmm. If error is less than 0, what are we going to do? We're going to y plus equals y step, I think. I got such a bad memory, I got to look back and forth. But then you add back the error. But dx doesn't change, right? We're just going to have to see this. Just feels weird. Is there anything else you do? All right, let's test it out with maybe our dummy app. Where's our draw event? Let's do 0, 0, 100, 100, and we're gonna do that as graphics red. And that was stupid. Why did we do red here? That is color, right? It's not. What's our surface window content? We need to make sure we don't overdraw as well. But, oh shit, are we doing that in our pixel anyway? I think we are. Then let's do another one. Let's do X, we're gonna do negative 100. Y, let's go down 50. And then draw to window content dot width plus 100, so we overdraw. And then the height, we'll just do 150. So the Y, it'll draw off screen from the left, down, off screen to the right. And then let's do one more that's wonkier, where it's 200. And let's start at 10, and then we're going to draw backwards to 50x and down to, let's make this, yeah, who cares? Let's just do it as 50. What other color do we got? Color red, let's do black maybe. Let's just see what happens. Okay, surface draw pixel. Yeah, that's the problem. Can we do this? Is this all we need? I don't love that, so let's just, we want them, we don't want to overwrite that though. Let's make it ugly at first, because I don't want to overwrite x, because we still need it. And then the max for y. Is the minimum of y and I think we could do the surface width. I'm saying x is the surface width. Oh, shoot. Value low and high. What's the... Oh, I did width there, and that should have been height anyway. Surface width. This seems like it might be too easy. Yeah. Oh, look. Oh, wait a minute. We don't want to clamp it because we're changing the value. So if x is greater than 0, greater than or equal to 0, and x is less than surface width, and y is greater than or equal to 0, and y is less than surface height. There's got to be a better way for this, but we're just doing what we're doing for now. Because I think you still want to do the increments, even if you're not drawing yet, because you're going to eventually come back on screen. Okay, well that fixed it actually. The thing, oh, we're not taking into account the steep one, so let's draw one more. Because remember how we didn't do the if statement in here? This was a little easier than I thought. Let's make a steep one from... What if we go from 0, 0, let's just move that over so it's not our way, to the x we only want to go over 10, but the y we want to go 100. Let's make it green. Hold on, I'm going to sneeze. Oh, wow, I couldn't get to it fast enough. On a Mac, there's a global pause for OBS, but it doesn't work here. On my Linux machine, it doesn't have global key bindings like that, or at least that I currently have set up. All right, that was wrong. So we're at 0, 0, and we're drawing over 10. Yeah, so this is inverted. It's because we swapped, right? It is because we swapped that it was steep. So we switched it this way. if steep. So we gotta get you do swap it. I wonder if this needs to be in here. Do we need it because we're swapping them? Do we need to take into account because Y in it? Yeah, you do. I'm now wondering. So my logic before was make sure the pixel function asserts that you're not drawing off screen. Here's my thought. I was asserting that you're not drawing off screen. Now you could just handle overdraw there, right? And just don't draw, you just say, oh, if it's bigger, then don't draw, just like we're doing here. But I think we hoisted it up to the collar. I don't know if that's a good long-term solution, but I feel like the collar can handle it better. Like if you have a bunch that you know is off screen, fix it early and don't keep, like, because you can call for all the pixels off screen, or you can figure it out ahead of time and just not even try to draw it. And this is forcing us to deal with that in the functions, but it seems like an easy way for applications to mess up by not knowing that. But if they're using all our primitive draw functions and they all handle it, then you shouldn't have to worry about it. I don't know. We might change our minds there, but for now it kind of makes sense to me. Holy cow. So it is, I mean, we just got a draw function. I'm doing everything we've done so far. I've been doing without AI or Claude Code or anything like that. I mean, the whole point is to learn. But I have had conversations, like I was on my little road trip and I was talking to ChatGPT about organizing stuff, not looking at code, but just doing the voice, audio, and talking stuff through. So I kind of want to have that Google. Let's think about it. Why are we getting half of X? So we're getting half the width. Let's just see what we do with error. There's just too many if statements in here too. We're not short-circuiting. We should short-circuit somehow once we're off screen or get on, but let's just leave it brute force for now. We can optimize later. So all we are doing is subtracting Y until we have an error, until the error is accumulated enough. But if error starts at half of X, say X is 10, we get 5. I generally, let's see if, whoa, they're doing something totally different. And I noticed we don't have an E2. E2's common in the implementations too. I've seen that in my other ones where you have like an error and an error 2. Calculate the temporary error value. Let's just read it real quick. So we are doing this, but we're doing it every time. We're doing it no matter what. Step X is just 1. And we're doing that with our normal increment here. I don't know. Like ours is working. Can we do this? Let's see what. Like. Do they have? Let's see if they have. Oh, okay, they don't. What file is this? Painter. They probably have a fairly optimized one that we aren't. Why? Where's all their painter stuff? Painter, Skia. Oh, they're using Skia now. I don't know that they're. Can we look at the file at that time? Do they have a steep? No. Fill rack, clear rack. Is there no draw line? Yeah, where's that? Holy. Oh, that's kind of cool, actually. They do the special case because it's a lot faster. That's what we should do. Yeah, I was gonna do these, like make you have to call the horizontal or vertical. But if I do this, we can optimize. We can make the API better and just handle it for the user. That's cool. So here's their set. We're at their. What in the world? That's just too complicated for us. That's more than. Let's go. Any of these people know what they're actually doing? Good God. That's beyond. That's not what we're looking for. All right, well, I don't know. I might leave it for now and we can research later because maybe I just need to read the. I don't want to bore everybody with me having to read this, but. Oh, but we're using i32s. I think this is there an integer version of this or anything? Alternative. I don't know if we care about integer only. Like, stuff's optimized for floats now. And I don't even understand these, actually. Like, I kind of do, but there's certain symbols that I don't understand. Is that delta x? Or they're using the D as their error. I kind of like that. All right, let's go on. We can also let's do something cool here. Let's just commit what we have. We don't care about that, but we do care about the line. Surface. Let's make this better where we go. We're going to draw 3 lines. We're going to draw from 0. Let's draw from -1 to -1 to make, this is going to exercise our validation, to window content width plus 2 to draw off screen. Window content height plus 2 because of our -1s over there. That's cool. Then we're going to go the X is going to be the Y will be -2 and the width plus so this is top right corner, and we're going to draw the bottom left because we're going to draw top left to bottom right, top right to bottom left, which means the X would be -1 and the Y would be window content height plus, is it 2? That does not feel symmetrical. Let's just do it. Let's just do red. All right, that looks good. Sorry for the quick break. I think this worked, right? Yeah. Well, what if we... Oh, that's... Ooh, what do I do there? X... It's saying that X was over the width. Wait, this is saying... Come on, what is going on? Might as well just have some little extra goodness to debug. Oh, it's coming through the same as the width. That's okay. Draw a line. But how is that happening? If we're only calling it if it's... Can I debug that? Will it? I don't know if it's gonna catch it. What? I gotta run it from like a file that's in the root or the status window to make it make sense, to be relative to the root directory. I don't know. Let's do the mini windows, GDB mini windows. I don't know if it'll catch. Don't go download a bunch of crap. We're not even using SDL3. Why? Why is it using SDL3? Wait, what is it? LDD. Why the hell is it getting SDL3? Did it run? Temporary breakpoint. Run. I know what that is. It's because of that path. I am going to hard code this just for now so we can get on with our debug. Failed to control your operation not permitted. Why are you tripping, Andrew? Let's just close this up. Let's get rid of this. Can you just do GUI? I don't know why I'm doing start then run. What the hell is going on? All right. home streamer. So, oh, what the hell? All right, that works. We're gonna make clean, make build. Now we can actually run it. I wish you would die. Terminate. Let's try one more time. GDB, run, yes. Run. There's Terrarium. This is just a mess to watch, sorry. Okay, here we go. I'm hoping that we can get a backtrace to ensure that it's calling from where we think. So it is from draw line. Oh, yeah. I know exactly what it is. We actually even called it earlier. It's because when we do this last minute swap here, so we could invert this. You can put it on each one of these after you change it, but we could also invert those, but all right, so if x is less than 0, or x is greater than or equal to, these are ors. If x is less than 0, or it's that, or y is less than 0, or y is greater than or equal to. Yeah, it can't be the equal to, so that's what we want. So many if statements in here, and it's kind of a bummer, but you're continuing on everything. You doesn't work because we're not still doing this. Let's just. Sometimes I feel like I would keep working on this, but since you're watching, I'm trying to make it not so boring. We have to. That's why too. Because we're swapping these, we need to check them against the other values. I think that's gonna be exactly what we need. Yes, it's way too many if statements to be that much branching is terrible for every single pixel that it's got to go over, so that sucks. But for our purposes right now, again, we can always optimize. We'll bring in like some optimization passes in the future, but can't crash now, right? We're off screen. Why does it not hit the corner? What's the second line? I mean, we're drawing, but shouldn't that be right there? No, it's not log, it's dummy. All right. Let's make our lives a little easier. We'll go. We're going to draw all on screen. All right. These can be Z. We're just making them on the corners just to kind of do a little debuggy. All right, yeah, that fixed it. I was just going off screen a little bit. What if I go -50 and -50? But we also need to let's go +50 and +50. It's probably not exact because we're still off by 1, but I want to draw off screen to ensure it's working like we expect. Oh, it's because this has got to be more gradual. That's why I was messed up the first time. That's fine. We're happy. I think this is where we want to be. All right, we're drawing lines. How much time is this? It took longer than we thought. It was a little easier, and it's not perfect, but we're at an hour. If you were here to learn on this one, this is probably the worst one because this is the one I feel like I explained the least, and honestly, maybe even understood it the least. But I'm going to go read the Wikipedia article, and I'll do a little follow-up. I mean, most of it makes sense. This part I don't totally get. The error 2, why other places have error 2, and this seems like... Hold on, I'm going to sneeze again. Sorry. And this one seems like there's too much branching logic in here. There's got to be a cleaner way to do this. You don't want to clamp or min-max it. Let's see my C++ version. Yeah, this one, draw pixel, actually does, you know, it handles this. I don't know, maybe that's the... Is that the move? I just kind of would like to know if we're doing like massive overdraw. Maybe I should make a comment about that. Have I already? All right, we are. All right, I'm okay with that. You can go. We don't need that change. That's good. That's good. I don't care about that. We know those work. So let's unstage everything. Yeah, I need to know more about this. This is going to kind of open up some stuff for us. That's why I wanted to get it in place for triangles and then triangle rasterization or filling, really. But you don't even need the line drawer for the filling. But line drawing and triangle filling are two things that I just take for granted. So I'll follow up with this one after. I'm gonna deep dive and understand it. I need to be able to explain this a little bit better. So I could. I don't know if I'll always remember the error stuff for implementing from first principles, but I do want to understand what we have and maybe improve our comment to really explain it. You know what? Do I have an old? Let's look at one last thing. I think I don't know what I am. Is this the one from 5 years ago? Oh, this was in C. I think I started converted to C++. Whoa. Is this what Pikuma did? We get the del. That's our dx and dy that we had before. Longest side length. That's our. Oh, that's our steep. Is it steep? But we're checking if it's steep. But yeah, we're just getting the longest side length, whether it's X or Y. The increment. Oh, is this? That's freaking interesting. Are we already committed? No. Let's add this. I'm curious about that. I'm going to throw the implementation in. That seems a lot more simple. It doesn't, I mean, there's similar steps, but it doesn't look like the same implementation. We're gonna need that. You know what else we might need? I'm just gonna. I just want to do that so I don't have to rewrite that out. See, I have better comments, but I think I was pulling these from, I know I wouldn't have drawn this out manually. That might be from, once I learned it, I used a lot of the comments from Pikuma's course, which is a freaking awesome course, by the way. I might even go back and rewatch that. I was hoping this was Bresenham's, because if it was, I could rewatch the video for a good explanation and understand it more deeply. I think before I rushed through it, because I was so pumped to be moving along through the course, I remember not understanding this totally. Alright, so what we're going to do is, it's going to be I32, perfect. ABS is I32 ABS. Float is F32. Oh, that's an integer though. He is using float. Is that what's making it more simple? Oh, man. What the hell is... Wait, current Y is already a float. What is round? Oh, double. And then I bet this is F32. Oh, no. We're rounding. That's kind of ugly, but I just want to see if it works. Because round takes a double, so current X and Y are being implicitly converted to double, so we just do it manually to show it. And it's not double. For us, it's F64. And then round returns. Oh, I could do round. Let's do that. I could probably, I need to implement this myself. So round defaults to floats. That's fine. And then we have to convert back to I32 because that's what our pixel is going to take. I might have to implement that. I don't know if I do know how to implement that. If it's might be simple, but it seems like there might be corner cases or not. All right, let's just see if it works. Okay, well. This seems a lot more simple. I mean, I don't know how much, if it's slower, faster. The increment. That's just so much more simple. me see. Seems what? Much more simple. What? So this is how I've been using recently. If I don't understand something, I'll talk to it about it, but not. I don't want the code, you know. So we want to understand. Oh, DDA. That's man. I should have known that. What are the costs? It's slower. Very simple to write and understand. I mean, we are heavily accelerated. I think I'm going to do this one for now, actually. I think this is, I prefer this. DDA, yeah. Switch to Bresenham once you understand this, because this one's just way more understandable. Like we can move on with our life immediately. And what we can do is change this. We're going to commit to the last one, and then we're going to update the comment. Add DDA line drawing. And there we go. I like that. All right, well, we switched that up pretty quick, but I think it's so much more understandable. And we don't care about performance right now. Quite a bit of casting going on. I don't think anything's too crazy. You could do immediately convert these to F32. This is F32, but I don't know if longest side, I mean, we're converting it to a float anyway. These are absolute values from integers, so if this was F32, it doesn't matter. Like, nothing's going to get truncated because it's already a 32-bit integer. All right. I prefer this. I'm going to stick with it. I was going to immediately, I'd like to turn these to static, hide them, and use them when, you know, x0 and x1 are the same. But currently it takes a length, and I just did that to ensure you couldn't accidentally make x and y different. But you can't do it. It's not as simple as you would think, because if you're drawing from right to left, then it becomes a problem. This assumes left to right every time. So we could add a fix me. Right to left. Is that it? Okay. Is there anything else we want to do right now? You could do triangle, draw triangle or something. But DDA, I had forgotten about that. I want to get our own round function as well. Is that the last thing we could do? Let's check our time. 125. Let's just look. I don't want to use the standard library stuff. I think it's all built in. This is useful. They usually have a decent implementation. What is it under math? What am I looking for? Round F. Yeah, this is where this is, oof. Is that because it's super optimized? This works. Let's learn something. Oh, dude, are we gonna have to handle a bunch of this in our OS? There we go. Is that... Oh, will the casting do it for you? What does a C compiler do? What's the rules for rounding to I32 in C when casting? Because why you would maybe positive numbers, it acts like floor. That's why. We don't want that. We want, yeah. You want to add 0.5 because you want it, if it's at 5, you want it to hit 4, so then it does floor on it. That's actually okay. That makes perfect sense. Yeah, let's get rid of that. Where does that come from? Are we importing that? No. How the hell are we getting it? And speaking of which, can we get rid of those? Yeah, then we can get rid of math. And does that make this break? Yes. Okay, that's what we wanted. I didn't want that to automatically be imported. So we got rid of math. Because we're not using those right now. The whatever I just deleted. Sine and cosine. Static inline. F32. F32 round? Return. No, we want. Do you want to return an I32? Does that make sense? Kind of. Or I think you might still. I think I do want to return an I32. What's the point of rounding it if you're going to still get a float? So we want to cast to an I32 when we take the value plus 0.5f. I'm cool with that. And then we can even get rid of this. Our little standard library things, I don't mind these little kind of verbose because there's type safe, but I'm okay with that. I was using sign. Well, I don't know how to implement that yet, so let's bring them back. Bring that back. I do want to get rid of those though. Add and use F32 round. Was there something else in that AK library we wanted to do? Short and long. So long ensures 64 on the platform. I think that long on Windows might be 64, but we don't really care. We don't use Windows, so sign car. All right, and then oh, I could do a little bit better macro, but to automate this more, and I totally messed up. I've been thinking about doing this for a while anyway. Just putting these macros up top. Oh, but I don't have F32 then. Or F64, I mean. Is that going to throw up? I think that might throw up. So these are static asserts. Oh, sorry. 1 by 2, 4. My little macro trick wouldn't have worked anyway. Why does this F64 work? That is interesting. I hate big changes like that though, so they're kind of ugly in the code anyway. We just want them to blow up. We don't really need them visible all the time. So now we can get rid of this. Is there a sign intrinsic compiler? Just wondering, since we're always going to compile with GCC or Clang, if we can use their intrinsic, because our sine and cosine implementations, I mean, people make tables for them too for real slow processors, but that's not really a problem for us, at least currently. Let's make sure it's not somewhere else. The use of stood it. While we're here, there is a interesting, let's jump in here. Stood bool sets a variable, and I don't know if we need to set it. This one. I don't know if we have to define that. Like what's looking for that? I don't want to be like, I don't want to do this. I don't care. Like, this is our code base, so we don't need this check. I think we'll actually blow up here. If these are already defined, it'll blow up anyway. This is if you want to be like handle build environments and tool chains, etc. There are different variations, but we're pretty controlled. So, and people aren't building a bunch of stuff on top of our code. This is our little playground. So I don't think I'm going to add that. Boom, boom. All right. Let's call it. Next time, I'm not 100% sure what we're going to do, but maybe. Oh, did you see how that grayed out? What's that about? Oh, that's this dead one that's been sitting there, dead. Whatever. I could just do kill on it. For the next one, yeah, I was thinking about doing for the 20th video like a summary, but I think I'm going to wait till 25 and get a couple more things in to make it interesting for if somebody pops along and sees the 25th video explaining it. There's a little bit more to see. Some scroll bars, maybe some buttons. And also one thing I'd really like to get is, I don't even need, oh, okay, I can draw a 3D cube now because we have the line drawing algorithm. I actually don't need, I was thinking about filling it, but I don't need that for the first round. So maybe that's what we'll do. We'll change our dummy application to be like a little 3D cube spinning. That could be cool. All right, let's leave it at that. Maybe I'll do that in the next video. I might even have time today since we haven't been recording many videos. All right, take care. Bye.